Hi everyone, welcome back to Cody's Lab. So today I want to try making a cast iron object using thermite as the source of heat and iron. Something I've always wanted to try. Let's go see what happens. For this reaction I'm going to be using aluminum foil and black iron oxide mixed together just like this. The reason I'm using black iron oxide instead of the more familiar red is because I can pick it up off the ground. I'm also going to be using some of these soda cans. Just add a little bit of the oxide to them and then crush them flat. And then throw this entire thing into the volcano. So I've got a piece of pipe here with a cap on the end with a dilute mixture of hydrochloric acid and water. And I'm using this to strip the galvanization off this smaller piece of pipe. That way it doesn't burn off later. So I've made a slurry of bentonite clay and water, and I'm going to use this to wet some dry sand. And this will bind the sand together, make it sticky. When it dries, it'll be fairly hard and heat resistant. And this is what I'll be using to line the volcano which we'll be performing the reaction in. So I made the volcano structure with this pipe in place. The idea is the pipe will channel the hot molten iron out into a crucible. But the sand's wet, and I definitely don't want the sand to be wet near the hot molten iron. So I'm going to pull this out and let the sand dry by pulling air through there as a chimney effect. And I might even put a torch in there at some point to really bake it. So the crickets seem to really like it. Must be the moisture. I also put a screen around it to keep Mr. Digger here from digging it up. So now I've got to ask the question, what object shall we make? How about a cast iron pan? It might be pretty ambitious for my first try, but I like this pan. Let's use it as a mold and see if I can make another. So this pan is made from rather thin material, and generally the thinner it is, the harder it is to cast. And so I'm going to make it a little bit thicker by dipping it in wax. This will make it easier to cast because it's bigger, it's thicker. There we go. I might give it a couple of coats just to make it extra thick. Just some candle wax that I melted down. So this is what I've come up with. The pan has a few coats of wax, making it slightly larger, and I've also added a bit of a design. So that'll be really nice if that comes out. To make the mold, I'm going to be using sand casting. To bind the sand, I'm going to make some sodium silicate. My source of silica is some amorphous silica kitty litter, which I'm going to weigh out a bunch. And to dissolve it and convert it into sodium silicate, I'm going to add about 300 grams of sodium hydroxide. Okay, now this beaker has a crack in it, so I can't perform the reaction in the beaker. I'm just using the beaker to weigh it. I'm actually going to transfer everything into a plastic jug with some water. Water's heating up, which is desirable to make the reaction happen faster. Okay, hopefully it doesn't get too hot to melt the plastic. The blue color is just from the pH indicator they add to the kitty litter. That's not really going to cause any problems for me. So here we are after several hours. Looks like it's all dissolved. For the sand, I'm going to be using some industrial blasting quartz. Any fine silica should do just fine though. I just happen to know that this stuff holds up well to the thermite. So here's my sand. I'm going to wet it with the sodium silicate solution. Now this is concentrated, and I'm going to add quite a lot. I find that if I add too little, it'll still set up, but then it crumbles upon drying. But I find that if I add enough to completely wet the sand with the concentrated solution, it sets up and it doesn't crumble again when it dries. I took one of my bee boxes, I put some screws in here to hold some wires to reinforce the sand. I put the whole thing inside of a plastic bag, which is sitting on top of a piece of plywood. So now that my sand is wetted with the silicate, I'm going to sprinkle it on the pan that I'm using as a mold, and then I'll pack it into place. Okay, so there's the first layer of sand packed in. I'm doing this in layers because I have tried this by filling the whole thing with sand, and the center of it, the most important part, didn't cure. The bottom, unfortunately, was not set, and so I'm doing it in layers so I can make sure to cure the whole thing. But to make sure the layers don't separate, dang it, I'm going to add some little pieces of wire just as some reinforcement for the next layer to grab onto. Now I've added the reinforcing wire. I'm going to also poke some holes through the sand to make the gas be able to move through it more easily. I will try to avoid hitting where the pan actually is though. Kind of go around it. Now I've sealed the bag around a tube which is connected to a tank of carbon dioxide. I'm going to open the tank a little bit to let the CO2 fill the bag. Okay, turn it off. I don't want to fill it too much and have it lift up the mold. There you go. Now the CO2 will be absorbed by the sodium silicate, forming sodium carbonate and silica gel, which will bind the sand together. So I let it go for about an hour and a half, probably longer than I needed to. I don't think you can go too long. Let's see if it hardened up. Okay. There we go. Just like clumpy brown sugar. Excellent. Now we'll add the next layer. Actually, on second thought, all the sand that needs to withstand heat is already in there. The rest of it is just structural. So to save on the sodium silicate, I'm going to mix up some of the cheaper play sand right here with some Portland cement. Basically make a concrete. It's just gotta be structural. Maybe this will come back to bite me. I don't think it will. Guess we're gonna find out. Okay, so there it is. Box is full. I'll just let this set up and then dry. So I've let it sit for a day. Yep. The concrete's hard. Now I need to flip this over so we can do the other half of the mold. There it is. Sand's good and hard. Ooh. Okay, it's not hard right there. It's got some soft spots. Have to fix that. Maybe I'll put the bag back on and give it another blast of CO2 on this side. So I put this here to keep the sun off of it so that the wax doesn't melt. Let's open it up. Yeah, it's all hard. It's time for the next box to go on, which is right here. Basically do the same thing, but on top of this one. But to keep the different layers of sand from sticking together so I can get it back open, I'm going to add some foil to it. So there we go. The first of a ton of foil we're going to be using for this project. I'm just going to take this and cut the pan out. That way the second half of the mold can have this portion. This will keep the boxes together as well as making sure they go back in the same place. Yes, I'm using hinges. I couldn't find my brackets, but these should work just fine. So I'm now adding the vent tube and pour spout, just like that, using some wax to stick it down. I'm putting some reinforcing wire into the sand in the middle of the pan where it needs to be strongest. Okay, the sand's in. Now I need to put the bag on, put the CO2 in to cure it. Okay. It's hardened up. The surface is a little loose. I might have to blow some of that out. But there we go. Now I'll just add the concrete mix. So it's the next day. It appears to have set up. I'm going to pull this piece of pipe out. There we go. And now I'm actually going to flip it over to open it. I'm worried that the sand didn't fully cure, like right in the bottom of the pan, which would be a problem because if I lifted this off, it's just going to fall out. I know the bottom half is fully cured and can handle being upside down. So maybe if I get that off, I can assess the top half and take steps to cure it. Okay. Okay. The form came out. I'd say it looks pretty good. Okay, is that hard? Okay, so that was hard. I didn't have to flip it over like that, but I'm glad I did. Pull all this off and prep the mold for the metal. Need to get this wax out of here before it melts in the sunlight. There we go. So what's going to happen is the metal is going to come in here. Any air bubbles are going to go out that hole and out the top. And any slag that's being pushed along hopefully will go off into this dead end here. And then clean metal will fill the mold. And then the air will be pushed out this vent. And I'll keep adding metal until hopefully metal comes up that vent as well. So here's the other half. You can see I made a little groove so the metal comes in. And any slag and stuff can be pushed along to the dead end before it starts to fill up into the mold. Anyway, I've got a little bit of the sodium silicate solution in a bottle. I'm just going to lightly spray the sand just to lock things in place so nothing falls down. I'm going to put a little bit of carbon dioxide on here to cause that to set up. That should lock all the sand in place. So now I'll just let them sun dry for a few days. Hopefully they'll be dry enough. We'll put them together and pour in the metal. Okay. It's dry, so now I'm going to assemble the mold. I think I might put something along here to act as a sealant to keep the metal from seeping out. So to make the seal, I took some diatomaceous earth, put it in a bag along with some of the sodium silicate solution to make a paste. And now I'm going to cut the corner off the bag like that. I should be able to just draw on here a thin line of this material, which will act as my seal. And now for the top half of the mold. Hopefully that doesn't squeeze out too far. I don't think it will. Straight down. Touchdown. Okay, now I'll just line up all the screw holes. Okay, so I'm just going to put a little bit of CO2 down into the mold. That'll cure that sealant. Get out. So I'm preheating the crucibles so they don't shatter when they get hit with a hot iron. Here's my pile of thermite. I'm gonna put the first log in here. You can see I've got some sand to protect the spout while the thermite reaction is going. So there's that. I'm gonna add some fine thermite mix on top. There's my water bucket full. Hey, I think I'm just okay. Crucible. Let's see if it goes. All right, volcano's going. It's very coarse thermite, so the reaction will be fairly tame, and that's by design. Double check the camera's going. Yep. Okay, time for the second log. Be blowing right at me, doesn't it? Go. And the last log. Okay. Is everything in the reaction? Now to tap it off. Okay. Seems there was a bit of an iron leak. And I'm just going to roll with it. You know what? Give me that. Okay, that was hot. But metal came out the vent. That's good. It looks like I lost a lot of metal escaping out the bottom of the volcano. Just don't want the box to burn. All right. I think I'll just sort of babysit things while it cools. Put out any fires that start, sort of thing. I hope that worked. I think I'm going to publish the video even if it doesn't. That was exciting. I don't know if you could see from the video, but the biggest problem I had during the pour was the formation of a crust on top of the metal. When I tip over the crucible, the crust was holding the metal in, and I had to like poke it to pierce a hole to get the metal to come out. I think it might have worked though. Won't know until I open it up. What do you think? Should I dump some water in this? It's really nice to do. It's kind of fun though. I can feel the ground vibrating. Oh, now it's picking up. Made my own hot spring. Alright, so it's cooled off. It's still not cold enough to touch with my bare hands, but pretty sure the iron's solidified. Alright, let's open it up. Let's see what happened. Okay. And the castings seem to hold up pretty well. Well, I know it got hot in this area because the sand is there. Looks like the metal flowed exactly how I wanted it to. So there's the vent, there's the handle. The metal filled the mold. Looks like it melded a lot of the sand. Basically having to grind glass off of it. Unfortunately, the metal appears to be fairly brittle. I think I'm going to try it again, but instead of using aluminum foil and cans, I'll use like mill turnings or something. That way it's mixed better. And the reaction's more efficient, doesn't leave as much aluminum in the final product. Alright, I'm going to drench it. It's too hot to handle still. Yeah, you can see the chicken. I was hoping the sudden shock would help dislodge some of the sand. It doesn't appear to have. Oh, maybe it did. Okay. So I see the metal kind of like stopped. It's got these little folds and bubbles in there. That says Cody'sLab. That's pretty good, I'd say. Yeah, the metal's very brittle. Need to be careful with it. I mean, cast iron's brittle anyway, right? I might still be able to use it as a pan, as long as I don't break the pan itself. Sand is not easy to remove. I'm just gonna have to spend some time picking at it. So there it is, a cast iron pan produced using a thermite reaction fueled with cans, foil, and sand. It's not perfect. In fact, it leaks a little bit. I decided to leave it a little bit rough because I kind of like the look of it and it tells a story. But for a first attempt, I'd say that's pretty good, yeah? Let's go see if it'll fry an egg. Broke the yolk. Well, guess I'm having scrambled eggs. Alright, that's pretty much it. Let's give them a taste. The handle's hot, so I need a rag to hold it. And it's also a very heavy pan, so it's kind of hard to lift. But here we are. Let's get a taste test. Well, not bad. Could use a little salt, but that's not the pan's fault. It is functional. Very nice. So I made a cast iron pan with thermite. I've always wanted to try this, and I think I'm going to do it again at some point. If you have any pointers for how I could maybe improve the process, I'd love to hear about it in the comments. Hope you enjoyed. I'll see you next time. So I'm going to go through and examine my little volcano here. First, I'm going to dig up whatever was hot, see what that was. And there's some blobs of very interesting looking iron. Looks like it's mostly the aluminum oxide slag. Yeah, look at that. Sparkly sapphire. I think most of my excess iron that I added is just in the slag. I'm going to look at this and see where the metal got out from. You can see all the reinforcement that I put in the sand. Might reuse it. There's the lava tube, essentially. So that's what happened. It melted down through the sand right there. Right between where I had this rock. Yep. Almost looks like a piece of fulgurite, don't it? There's some iron. Let's have a look at this. You can see I put some wires on here to give it more strength. It definitely held up. This is aluminum oxide with a little bit of sand melted in it, probably. Here's that sand I put in the bottom. You know, it wouldn't take much just to refurbish this so it can go again. Yeah, it did eventually plug up. I guess that's why there's still some of the alumina in there. There was nothing left of that pipe. It all got melded.